In 2026, we can see AI everywhere. If you are applying for the on-demand job role of AI engineer, ML engineer, or data scientist, these are the 10 questions you'll definitely be having on your first or second rounds because these questions are considered as the foundation of machine learning. So, in this video, I am going to teach you how to answer these questions and what is the exact answer for these questions. Let's get started. First, what is machine learning? As a human being, I have my own brain to think, right? If someone is asking a question, I already have something stored based on my past experience. Based on that, I am giving them an answer, right? As similar to that. If I am giving that ability to my machines to think based on data. So I'm seeing something and they are reacting. If I am seeing a person and I'm moving on the different way. If someone is asking a question, I'm thinking and answering as similar to that. If I'm giving a data to my computer, based on that, if my computer is processing and giving me an answer, that is called as machine learning. Maybe in data science, it is different. In machine learning, I mean in artificial intelligence, it is different. If I am using machine learning for data science, how it works. Specifically, if I want to take a useful information from my data, that is called as data science. If my goal is automation, that is called as artificial intelligence. But for both, I can use machine learning because for both technologies, I want my machines to learn. That is how machine learning works. Now, what are the types of machine learning? When it comes to machine learning, there are three important types. First type is supervised, second type is unsupervised, third type is reinforcement learning. But what is supervised first of all? If I am giving data to my machines to learn, if I am giving the data with labels like this is an apple, this is a banana, this is how it looks like. I'm giving labels, right? That is called as supervised machine learning. If I'm not giving any labels, I'm giving just the data and I'm letting my machines to learn by itself. That is called as unsupervised machine learning. Now, what is reinforcement learning then? As a human being, I know if I'm doing something wrong right now, I should not be doing this in my future. So I'm learning from now to my future. If I did something wrong in my past, I'll not be doing it now. I'll not repeat it now. So based on my past memory, I can learn. As similar to that, machines can learn based on their past memory and based on their rewards they receive. That is called as reinforcement learning. So now what is supervised learning? Learning with labeled data. What is unsupervised learning? Learning with unlabeled data. Then what is reinforcement learning? Learning with past experiences as similar to human being. Okay, the third question is considered as the most important question. What is data set when it comes to machine learning? So this is actually considered as the foundation of machine learning. How and why? As I already mentioned, machine learning is actually a technology which will be learning from data, right? So what it means? Data set is the foundation of machine learning algorithms. In that data set, we do have two types. One is structured data and another type is unstructured data. If I have table data, which looks so organized, that is structured data. If I have image data, audio data or video data, which is not organized at all, that is called as unstructured data set. What is regression and classification? What is their difference? We know what is machine learning, right? So regression and classification is considered as the basic type of machine learning algorithms. Regression is used for predicting the future. Simply, I could give you an example. If I want to predict a house price, I can predict that based on number of rooms, square feet, how far away it is from the main city. So this kind of data has a solution. For that solution, I can use regression algorithms. Now, the goal is finding a number, continuous number based on the continuous numbers I have in columns. Now, what is classification then? I could give you a simple example so you can get it. In your email, you have so many folders, right? The first is primary mail, and specifically you have something called spam folder. How it is happening? You are receiving so many mails, something is already falling under spam. How? It is being classified. How it is being classified? Based on the keywords. Specifically for advertisement, they will be using some words like discounts, offer, right? So based on that keywords, the automatical AI that we added to my email system, it will be classifying it. So which is a normal primary mail, which is actually a spam. So that kind of process, that kind of automation comes under classification. Now what is regression then? Finding a continuous number based on continuous numbers. So both is about prediction, but regression is about a number and classification about finding a category. What is deep learning? In AI machine learning, this is an important type. In data set, I told you about structured and unstructured data set, right? So for handling structured data set, regression and classification are more than sufficient. What if I have unstructured data set or the structured data set is too complicated? My basic machine learning algorithms will not be working there. In that scenario, what I need to do is I need an algorithm which understands data as similar to how my brain understands. That is why I am using deep learning algorithms. This is specifically designed for understanding unstructured data like image, audio and video, and also for complicated data, because in an inbuilt structure it has neural network which works and which tries to imitate human brain. So that is how this deep learning is powerful when it comes to real world scenario. What is train, test and split? This is a common question being asked in every interviews, but most of the beginners struggle. Why do we need this? First of all, I want to make my machines learn, but I want to know if it is learning properly or not, right? So for that, what I'll do is I'll split my data set into two parts, 80% for training and 20% for testing. So if my model learns properly with my 80% of training data, it should be working properly on my 20% of testing data. So what I'll do is I'll split my data set into training and testing data. So that is the purpose. For testing, if my model is working on new data or unseen data. What is overfitting and what is underfitting? Actually, it is a beginner question that's being asked to everyone. This question is the most important among all these 10 questions. But most of the beginners fail to answer this in a proper way. If I'm having a data set which is very simple, I'm giving a complicated or powerful model. In that scenario, what my model do is it will just memorize the data. So in that scenario, if I'm giving a new data, it will not be performing well. So model is big, my data is small. That is called as overfitting. Now what is underfitting? It's straight opposite. My model is very small and my data is so complicated. So even in training data, it will not work. But when it comes to underfitting, it will not be working well on my testing data. Model evaluation. What is this and why do we need it? I trained my model. I tested it. I want to know if it is performing well on new real world data. So for that, I'll be having evaluation metrics. It is like giving marks to my examination. So what is their percentage likewise? So that is called as evaluation. So that is why we need evaluation when it comes to machine learning. Ninth step is feature engineering. This is considered as the most important question as well, because in my data set, one column, one value is something that I'm going to predict, that is called as target. Now the remaining columns are called as features. In image, based on how it looks, how sharp it is, I can find which image it is. So feature engineering is a step of improving the quality of the features. If I have 9 columns in my data set as a feature and one target is something I need to predict. So on those 9 columns, which columns are important? And if I have columns like alphabetical values, if I have 4 categories, I can convert them into numbers. That is called as encoding. So I'm doing this because my machine learning model easily understands. So all these steps I'll be doing under feature engineering. In a way, my machine learning model understands my data better. So goal of feature engineering is to make my machine learning model understand the data better. So what I need to do is I need to convert that data into a useful format. Finally, what is machine learning pipeline? This is where most of the beginners fail. because step-by-step process they need to explain, right? The first step is data collection. After collecting all the data, I should be creating a proper problem statement. This is the important and most powerful step. If you create a proper problem statement, the most of the problem is solved here. Third step is data cleaning. You need to be spending most of the time here. Fourth step is feature engineering. This is where I'm giving importance to my model, I mean the data, and treating them. Fifth step is exploratory data analysis. I'm trying to understand my data. Sixth step is building a machine learning model or choosing a right machine learning model. Then the seventh step is evaluating. So training and testing. So that comes under the seventh step, followed by that evaluating based on the evaluation metrics like accuracy, RMSE values. And the final step is the most powerful one, deployment, giving my model industry ready so that the professionals, the clients who gave us the data will get something that is useful for their business. I believe this video helped you in understanding how to answer these 10 powerful machine learning questions when it comes to interviews. So, if you have any doubts, without any hesitation, drop them in comments. We'll meet you in next amazing video.